Now, to start with AI, I think I want to just give you, there are several definitions of AI. I'm sure you must have explored about this topic in the past, and there are several definitions of AI. And one of the simple definitions that I like to stick with is it is basically an intelligence of a machine. We have human intelligence, then obviously there is an intelligence of machine. Machine need not to be more like an hardware, it can also be a software. But in the industry, what I've seen is that with respect to this definition, the industry is more comfortable with calling a computer system as an AI that can mimic, the human-like intelligence. Some of the basic human-like intelligence, such as our ability to see, our ability to understand the language, our ability to speak, decision making, learning, etc. Right. Whereas in the academia, it is more looked at as a branch of computer science, and which means that there are various different domains within computer science, which has been leveraged today to build techniques and algorithms, and which is obviously with an aim to create a kind of a computer system to mimic human-like intelligence. Okay. Now, whenever we talk about AI, we definitely talk about machine learning. And to give you an idea, while AI is a broader set of technology concept, whereas a machine learning is a subset of it, machine learning today provides an ability uh, for any system to learn from the data. There are various different types of learning methods within machine learning, like supervised learning, unsupervised learning, reinforcement learning. Likewise, there are certain very specific techniques, like say, for example, computer vision. So this helps an AI system to, identify or recognize an image or a video. Natural language processing is on the domain of the um, languages. Voice recognition is for the voice recognition, right? So likewise, there are some very specific techniques, whereas a machine learning is a broader set of methods and techniques, which gives an ability to learn these computer systems from the data. So as we're talking about machine learning, let's also try to understand a little bit more about how machine learning really works. And I think the better way to think about machine learning is in the context of a traditional software, right? So we all are familiar with softwares. So if you see how any software would work, you basically need to have a program, right? A program could be a set of rules, a combination of rules that has been designed to solve a specific problem or for a specific task. Now, this program, when it is available, now the user can interact with this program, and then this program will generate an output, right? It's quite straightforward from that sense. Now, in comparison to this, the machine learning, the way the machine learning is designed is slightly different. So for the machine learning to work, you have to train a machine learning model, right? Now, to train the machine learning model, you would require the past data and the output that you desire the machine learning to perform, right? So, for example, if you want a machine learning to identify the frauds in the payment transactions, you have to train a machine learning model by providing the past data, the past fraudulent or non-fraudulent transactions, and then train a machine learning model. Now, once you train that machine learning model, so then that's basically what a program here represents. Now, this program or a machine learning model will start interacting and on in the real world. And as and when the new payment transaction comes in, it starts identifying frauds and non-frauds, for example. Okay. I hope this gives you an idea about how machine learning typically works. If you try to understand this a little further with an example, let's look at how you would create a software for the same example of identifying frauds in the payment transaction. So as I said, you will basically build the rules and the combination of rules. You can call them as rule engine. So this is your software, and as and when the payments comes through the data into this software, which is a rule engine, and it starts identifying frauds and non-frauds, right? So this is how you would do it. Whereas in case of machine learning model, as I said, you first need to build a machine learning model which is trained to identify the frauds and non-frauds. So what you would do to train that machine learning model is you provide the data about the past frauds and non-frauds, for example, and then you create a machine learning model. And then when you apply this machine learning model on the real world, which is once the new payment starts coming into picture, Once they pass through this machine learning model, then it basically identifies the new frauds and non-frauds. Right? Now, what is the real difference here? I think in the first case, in the case of traditional programming or a software scenario, since you are building the rules, most of the times the rules are static. You can visualize the rule to be this straight line in this particular diagram. And then the way it can differentiate between the frauds and non-frauds is, as you can see on this diagram, right? The green color basically indicates the frauds and the red ones indicates the non-frauds. And it's quite clearly doing its job. It is dividing the frauds and non-frauds. But as you can also see, there are a lot of non-frauds which are not classified as frauds, which are in the same way the frauds are not classified as frauds as well, right? Now, for the same kind of scenario, if you use machine learning, it would look typically like this. It won't be like a straight line because it learns from the vast data. It has a capability to learn those patterns, and then it will be able to do a better job of classifying frauds and non-frauds. Right. Now, what are the other advantages? Like in case of if you're building rules in the traditional software, as you can see, it can do a lot of false positives, which is nothing but classifying frauds as non-frauds and vice versa. And it requires a lot of fine tuning to build these rules. You need to have domain experts, etc. And it is extremely high maintenance. Whereas in the case of machine learning, I think as you can see that even machine learning models tend to make mistakes, such as they have classified some of the non-frauds as frauds and vice versa. So, but it will be much lesser than going with the traditional rule. And on top of that, a machine learning model can self-learn, right? It can be set up in such a way that it can keep learning on the newer data and it can become more accurate. I hope this gives you an idea about how to look at machine learning and how it can differentiate from a traditional software.